Hello all. Today I want to talk to you about how you go about finding current limiting resistor. So if you guys remember, we have this situation where you have to have a resistor in front of LED to prevent it from burning out. Now the current at which your LED will burn out is probably around 20 milliamps. So you need a resistor large enough to prevent it from burning out. But there is also another problem because you need a resistor also large enough to prevent it to actually small enough to actually light it up. So if we look at the curve again, this is our LED. I'm just gonna draw a little LED curve right here. We had this situation where you had the curve for your LED looking something like this. And this point over here is 1.83 volts. Now over here, I have the burnout point, right? This is the point where LED will burn out. Let's call this 20 milliamps, right? All right. Now, if you think about it, if this point has a V coordinate, it has to have an I coordinate as well. That means there has to be some kind of current that corresponds to this 1.83 volts. And I don't really know what that current is. I'm just basically guessing that it's 5 milliamps. Okay, so my task is to find a resistor such that the current I have is bigger than 5 milliamps and smaller than 20 milliamps. So let me type it up. All right. So how would I go about doing this? Well, the best way to do this is just to pick a number. So the number I'm going to pick is going to be 20 milliamps, just for kicks, right? Now, generally, I would probably choose a number that is somewhat smaller because I don't want to be right at the edge of this envelope. But if I pick 20 milliamps and I put in exactly that resistor, I will have the maximum allowed current flowing through my circuit, and everything will be just fine as long as I don't decrease my resistance any further. So I'm going to try. So here's my current equals 20 milliamps. So before I can find the resistance, I need the voltage drop. Because if you guys recall, the Ohm's law is V over I times R. Now, if I have just current, I cannot find resistance. I need a voltage drop of this resistor. But I can easily find the voltage drop using the KVL. So if you guys recall, KVL says that voltage of the battery equals voltage of the voltage drops around the loop. Now, those voltage drops in my case consist of voltage of R1 plus voltage of LED. It does seem like I'm stuck because I don't have the voltage of LED, but actually I do, because the voltage of your LED is going to be your forward voltage. Now, why is it forward voltage? Because we want it to be forward voltage. We want our LED to turn on. So we're just going to say, well, the voltage we want this LED to have is 1.83 volts. Okay. So now using the KVL, we can find easily V of R1. This is just V over 1 equal to voltage of the battery minus voltage of the LED. And we can just plug in numbers straight away. We're going to have 4.5 minus 1.83, and that equals to 2.67 volts. All right, so now that we have the voltage drop and we have the current, we can finally find the resistance. So first, I'm always gonna write down my formula, because formula is important, and I'm gonna write down the formula I'm actually gonna use. So this means resistance equals to voltage drop of R1, because you always have to specify which voltage drop or which current you're using, over I. All right. So this is 2.67 over 0.02. Don't forget to convert your current. And when I run the calculation, let's see, I've got 133.5 ohms. Now, I always ask for three significant figures unless I ask otherwise, which means I almost always ask for that. So I need to round this number up, 5 rounds up, so this is 134 ohms. All right. So that is my resistor that is my current limiting resistor in its very simplest form, in the very first circuit that we guys built.